Good day everyone, myself Apurva Rajkumar, and here I am with my fifth project which deals with verifying the divergence theorem. So the body chosen is a lamp where my frustum is the light emitting part. Uh, I have a cylinder as its holder and another cylinder as its base. So we had to define a vector field, and this is my definition of the vector field, and the following are the images of the actual vector field, uh, the result of the MATLAB code. So here we can see how the uh, vector field has an x cube component, and since we are multiplying it with the x1 and x2, it is uh, expanding outwards as well. Next, we had to define a scalar field. Now, the scalar field we use is the divergence of the vector field, this vector field. And this is the result we get after using this scalar field. So before we proceed further, we need to know what divergence theorem actually is. So divergence theorem actually relates the flux of a vector field through a closed surface to the divergence of the field in the volume enclosed. So we have our divergence and we integrate it over the volume. With this will be equal to the flux generated over the surface area. So we had to manually calculate the divergence over the volume, and here here's my first body, the frustum, where we defined the parameters. We found the divergence, and then we integrated over the volume, and we found the value. Similarly, for my body too, we did the same entire process. We defined, we calculated the divergence, and then we just integrated over the volume. And similarly, we did for our third body, which have the same parameters because they are both cylinders, and we calculated the divergence, and then we can finally calculate the total divergence in the enclosed in the volume. So these are my normal vectors used for each and every surface, and this is my MATLAB code where we basically define the initial parameters, we define the parameterization of the body, grid, surface, and curve. We find the volume Jacobian, we find the area Jacobians, we input the normal vectors, we input the scalar field, which is basically the divergence of the vector field, and we also input the vector field. Similarly for body 2 and body 3, and we finally define the scalar field and the vector field. So this is my output, and we can see that the divergence integrated over the volume of the body is 5.2077, which is equal to the total flux of the vector field over the surface area of the body, which is equal to the hand calculated uh, value 5.2077, and this is my output. Uh, Thank you.